So we're going to start with the probability of non-mutually exclusive, so events that affect each other. And then we're going to do the probability of just mutually exclusive events, so kind of get rid of the non. So those are events that don't affect each other. So let's talk about a normal deck of playing cards. So there's usually 52 cards, right, in a normal deck. And because there are 4 suits, drawing a 5, so the first question asks us, what's our probability? So probability of drawing a 5 or a black card. Okay, so our options are, in 52 cards, we have our hearts, we have our diamonds, we have our spades, and we have clubs. Looks like a clover. Okay, and actually, I should really do those in black. They'll help out a lot. So we have our red cards and we have our black cards. Oh, spade's getting worse. Okay. So, for instance, drawing black cards, because it's split up this way, half of the cards are black, right? So that's half of these 52. So let's say we have 52 times 1/2. What does that give us? 20 something? 26? 26 cards are black. But we also have a 5 in each of the decks, which means you have 4 out of the 52 cards, okay, of drawing a 5. But the problem is we have overlap, right? Just like if we were to draw a Venn diagram, you can draw a black 5, and we don't want to double count those when we go through this. So when we're going through this probability of non-mutually exclusive events, what we'll call this is we'll say probability of A is black cards, and probability of B, I'll do it in green so we don't get confused with red. Probability of event B is number 5. Well, because they're non-mutually exclusive, the formula is usually written like this, where we take probability of A plus probability of B, and we have to subtract the probability of A and B. Okay? So probability of A we have of black cards is 26 out of 52, we'll say. Okay, and you can reduce that fraction to 1 out of 4, right? Plus probability of event B, which is 4 out of 52. I just wanted to keep the denominators the same. Minus A and B. Well, how many black number 5s are there in a deck? 2, that's right. So event P, A, and B is actually 2 out of 52. So we subtract that 2 out of 52. Okay. So when we go to do this, our denominator, I kept them all the same, luckily, is 52. So if 26 plus 4 is 30 minus 2, so we should have a 28 out of 52 chance of grabbing a black or number 5 card, because they're non-mutually exclusive. Now, event 2 is drawing a 5 or a black face card. That's a little different, so let's go down a bit. Our options again, we had 4 number 5s, right? So from our diamonds, hearts, clubs, oh my gosh, and spades. Okay, we can draw a 5 from all of those. So again, we have a 4, and there's a total of 52, right? So we have a 4 in 52 chance. But black face cards, what are black face cards? Well, there's a jack, a queen, and a king, right? And they're in both of the suits. So how many black face cards are there altogether? 6. And can I grab at the same time a black face card and a number 5?
Yeah. Oh.
In the same draw. So no, I can't, because the 5 is not considered a face card, right? So these events are mutually exclusive events, okay? So we'll call these ME events, which means the probability for these 2 events We'll call this guy PA and this guy PB, probability of event A, are just adding the two probabilities together. So probability of event A plus the probability of event B. There's no subtracting because I can't double count anything. They don't affect each other. Like in the first one where we had black 5s, they affected. But because the black face cards don't overlap with the number 5s, we just add the two probabilities together, which is 4 and 52 plus 6 and 52. So we have a 10 and 52 chance of drawing a number 5 or a black face card.